There are many ways to prove theorems, and a really interesting and important way is what's called an indirect proof. This is where we want to prove something is true, and we don't exactly have enough maybe to get us going. So what we do is we try to get a contradiction. We assume that what we're trying to prove is false, and then work toward getting a statement that we know is a contradiction, that in fact can't happen. Once we have that impossibility, we know that our original assumption that the conclusion was false must be wrong, which therefore implies that the conclusion that we were trying to seek must in fact be true. So we prove the result in an indirect way, and that's why it's called indirect proof. Let's take a look at an example where we'll use an indirect proof to prove a neat result. So here's the result I want us to prove. We can think of this as a theorem if you want to. So given triangle ABC is obtuse, so triangle ABC is obtuse, we want to prove that triangle ABC is not a right triangle. So if the triangle is obtuse, it can't be a right triangle. First of all, the first thing I would do is just think through this. Let's not worry about the details of writing all the stuff down. We need the ideas first. Remember, if you want to prove theorems, you've got to first have the ideas for the proof and then articulate those ideas really carefully. Now, we want to do this in an indirect manner. So what we want to do is we want to actually make the assumption that the triangle is a right triangle. Okay, well, if the triangle is a right triangle, then one of the angles must be exactly 90 degrees. Let's call it A. Now, you look at that and go, well, A doesn't look like 90 degrees. That's wrong. But remember, this is just an artist's rendition. This is not necessarily drawn to accurate scale. So let's just pretend that's 90 degrees. What do we know? We know that triangle ABC is obtuse. That means that one of the angles has to be greater than 90 degrees. It can't be this one because that's exactly equal to 90 degrees. That's our assumption. So maybe it's, say, B. So let's suppose that B is the angle, which we know exists, that is greater than 90 degrees. Well, then this is greater than 90 degrees. This is equal to 90 degrees. The sum of these two angles is going to exceed 180 degrees. Uh-oh, that's not good. Because we know that the sum of all the angles of a triangle actually have to equal 180 degrees. That would force the angle of C to somehow be negative, which makes no sense. That would be impossible, and that impossibility shows that our assumption was false, and therefore this triangle is not a right triangle. So this tells me how to sort of shoot toward my argument. Namely, I'm going to use an indirect proof, assume that one of the angles is 90 degrees. We know one of the other angles is greater than 90 degrees. The sum of those angles is going to exceed 180, and we're done. Do you see how I first sort of put the ideas together, and now I'm going to try to actually refine it? So let's take a look at this together. So what we're going to do here is we're going to assume that triangle ABC is a right triangle. And let's let B be the obtuse angle, which we know exists from our given. And angle A, we will assume, is the angle known to be right, since we're assuming that, in fact, the triangle is a right triangle. Okay. So now let's take a look at some reasonings here we can take a look at. So the measure of angle B is greater than 90 degrees, and the measure of angle A is equal to 90 degrees. And this is just the definition of what it means to be an obtuse angle and what it means to be a right angle. So that's straightforward. If we take the measure of angle A and add it to the measure of angle B, we see we're going to get a measure that's greater than 180, because this is greater than 90 and this equals 90, so their sum has to be greater than 180 by the addition property of inequalities. That would imply that the measure of angle C is less than 0 degrees, because we know that the sum of the angles of a triangle have to equal 180. That's the triangle sum theorem. So what does that tell us? Well, of course, that just is impossible. So what that means is a triangle cannot have, well, we know a triangle cannot have a measure, an angle measure less than 0 degrees, and that's just the old protractor postulate that you might remember from early. And so therefore, triangle ABC is not a right triangle. The assumption that a triangle ABC is a right triangle is false. And therefore, we actually showed the triangle ABC is not a right triangle. And we did that using an indirect proof. We assumed the opposite, and we produced a contradiction. Tricky proof technique, but important.